So day 2 says, now that we're familiar, at least, maybe not completely comfortable with, but now that we are familiar with parabolas and their new form and our focus and our directrix in addition to our vertex, let's see if we can derive the equation based on pieces that we have been given. So remember that the standard form of a parabola, when it's vertical, is the x minus h squared is 4p times the y minus k. And when it's horizontal, the y minus k is squared, and it's set equal to 4p times x minus h. Hk is still our vertex. The h is always with the x, the k is always with the y, and we have a directrix and a focus. This is the thing from yesterday, just reminding us of what we've seen. Opening up, openings left and right, opening down if p is negative, to the left if p is negative. Okay, so nothing earth-shattering. We've seen this yesterday. Don't worry so much about whether we're taking k plus p or k minus p and all of that. Just think about whether your focus is the focus is always going to be on the inside of the parabola. The directrix will always be on the outside of the parabola. Okay, that'll help you not have to memorize so many little intricate details. So they want us to actually find the equation this time of a parabola that has a vertex at the origin and a focus at 2, 0. So start by graphing, and it's going to be a crude sketch, but that's okay. So vertex at 0, 0, focus at 2, 0. We already immediately know quite a bit about that parabola. If the vertex is at 0, 0 and the focus is at 2, 0, it's going to open right, isn't it? We're just trying to get the equation. Okay, so now is it going to be x squared or y squared? Y squared. Okay, so y minus 0 squared and x minus 0, and we have our 4p that's going to be with the x minus 0. Questions so far? Okay, so we're good? No? Good question. How do we know it's going to be y squared? So when we were told the vertex is at 0, 0, and we were told the focus, we know that the focus is always inside the parabola, and it's along this axis of symmetry. Okay, so once we know that this is our focus, we know that we have to be opening sideways. And when we open sideways, this is new to us, right? We've always dealt with parabolas that either open up or they open down. And this was when y was equal to x minus h squared plus k, or y was equal to a negative a times x minus h squared plus k. So the x has always been the squared term. The minute you realize that it's opening left and right, you know the y is the squared term. Up and down is x. Make sense? All right. So far so good? Now, we know something about p, don't we? The focus is h plus p. We're 2 steps away, right? Okay. That means our directrix has to be 2 steps away as well, doesn't it? Or these two won't be equidistant from the parabola. And we know p is 2 because we're 2 steps away. So now our equation is going to say, you can leave the 0 in there if it makes you feel better, or you can remove it. And remove the parentheses, 8x. And y is equal to 8x is our equation. Y squared equals 8x. Okay, where did I get the, which one? 8? The 8 is part of my p. Okay, P tells me how many units it is away, the focus is away from the vertex. Okay, so P units between vertex and focus, and P units between the vertex and the directrix. The X doesn't have to be in parentheses, nope. Okay, so now that we saw that we were 2 units away from 0, 0 to 2, 0, that means that P is 2. And that means our directrix will be 2 units away and perpendicular to the axis of symmetry. Okay, that's all. They just asked us to find the standard form. They gave us a vertex and an origin, or at the origin and a focus, and that's our equation. Now they get a little tougher because we're not always going to be at 0, 0, but away we go. Everybody good with this one? Ready for the next? Okay. Absolutely. Okay. Now we want the standard form of an equation of a parabola that has a vertex of 2, 3 and a focus of 2, 1. So again, crude sketch doesn't have to be perfect, but we want to at least see what we're working with. So we don't have to memorize a bunch of formulas. So vertex 2, 3. Focus 2, 1. Okay. So what do we know? Opens down. Absolutely. The minute you see that the focus is down here, the focus has to be inside the parabola. So quick sketch of it. We know it's opening down. So is the y squared or is the x squared? X is squared. Okay. So x minus something squared equals 4p times y minus or plus something. And we've got our general form. Okay. Couple hands, I'm sorry. The vertex will be in the blanks. I just want to get the general form of the equation so we know that x is squared and y is not. The 4p is the number that is used to figure out how far the vertex and the directrix are. Always 4p. Yep. Always 4p is that a coefficient. Our flashcards that we had yesterday didn't have 4p. They had something else, but that's what our book is using. Okay? So we got the general form. Now let's put the vertex into that, right? So make sure you're grabbing the vertex, not the focus. Vertex is 2, 3. The 2 always goes with the x piece. So 2, 3 with the y. And now all we have to do is find out what p is. Absolutely. Yep. Since both the points of the coordinates of the vertex were positive, it's negative here. But if this had been a negative 2 and a positive 3, then it would be x plus 2 squared equals some 4p times y minus 3 squared. It's always the opposite of whatever's in the parentheses. The parentheses are opposite of whatever the order pair is. Okay? All right. We're all good so far? Last thing we have to do is find out what our 4p is, right? How many units away are we again? 2. So since we're 2 units away, we know that our directrix would be 2 units away. That's negative 2 this time. Negative 2, the p is going to be negative 2. So our x minus 2 squared equals negative 8 this time, y minus 3, and that's our equation. And if it feels better to put the y on the left and the x on the right, that's perfect as long as you have the correct one squared to make it opening down. That's our standard form. That's what our book is calling standard form. Okay? And the focus and the vertex and the directrix, exactly. Yep. Because it's opening down. Yep. Yes, sir. Because we're opening down this time. Yep, down and left is negative, up and right is positive. Making sense? Yep, exactly. Had to use x because the focus was here. Had the focus been over here, we would have used y. A lot easier than memorizing formulas, isn't it? And I think that's the key, is to understand where things are in relationship to the parabola itself. All right, next example. Now we're giving you a focus, and now we're giving you a vertex and a directrix. So we don't have the focus this time. So we start with vertex at -2, 1, and directrix of x equals 1. So I'll plot my vertex, and directrix was x equals 1. So here's my x equals 1 line. And a parabola always opens away from, right, the directrix. And so if this is my vertex, my focus has got to be on the left-hand side. So a quick, crude sketch, we know it's going this way. Okay? And if it makes us feel better, we can put the focus in there, but we don't absolutely need it, do we? They didn't ask for it. How far away would it be? 3. So it's going to be 3 steps in. Okay, there's our focus. Always opposite the directrix, because the directrix has to be outside. Always toward the focus has to be inside. Okay? We said, guess what? This guy is 3 steps away. So this guy's got to be 3 steps away as well. Perfect. So hold that thought now. So which one's squared, x or y? The y is squared. So we know y minus or plus something squared equals 4p times x minus something, or plus. Okay, this time we have that lovely change of signs here to make sure we understand which is which. The x always goes with the x, so we're going to have what in our parentheses over here? Plus 2. The y always goes with the y, so we're going to have minus 1 there. And the last step is to find p. Because it's always the opposite of the point. And then 4 times 3 is 12, right? Is it going to be positive or negative? Negative. So y minus 1 squared equals negative 12, x plus 2. And again, if you want the x's on the right left side and the y's on the other, that's okay. But be careful that you don't put these in the wrong places. The x and the y. The x goes with the x. The negative 1 is because it's always y minus k and x minus h. Yep, in this case, y minus k squared, because we're opening to the left. Left and right, not up and down. Making more sense? Okay. Here comes another one. Now we want the standard form of an equation of a parabola with a focus of 2, 1 and a directrix of y equals negative 3. So we know nothing about the vertex this time. Has to be on 2, right? Because this is my axis of symmetry. And it has to be halfway in the middle, doesn't it? So what's halfway in the middle of the directrix and the focus? 2, negative 1. So we know it's opening up or down? Up. And we know P is 2. So is the x squared or the y squared? X is squared. So x is going to be minus or plus 2? Minus 2. Always the opposite of whatever the point is. And y will be plus 1. And p is 2, positive or negative? Positive 2. So we'll have 4 times 2. 8 again. Let me do one more. This is going to be a little different. Okay? I haven't decided yet. Yeah. We're going to get through at least parabolas and probably ellipses before we do a quiz. Yeah. Because which way is it opening? That's all it is. Yep. When it's up, P is positive. When it's down, P is negative. And when it is right, P is positive. And when it's left, P is negative. Okay. All right, last example. Now this time, we're telling you we have a vertex, and we know that the parabola passes through the origin. So this is the segue that I was talking about with that last problem, that example, or that last problem number whatever, 48 or whatever it was that we did in our assignment. So plot your vertex. All right, we're at 3, negative 3. And we know it passes through the origin. Good. So we don't know. There could be 2 answers here, right? Okay. Because we don't know if it's opening to the right or if it is opening up. It's going to cross through here. So this is going to be our, oh, thank you. Holy smokes. I blew that. That's not the vertex. Sorry about that. Messed it up. Okay. This is our vertex, right? So it has to either open up or it could open to the left. So I have to tell you which way it is because it is an ambiguous case, right? Okay. So it will tell you. Okay. So it will say, in this case, let's make it open up. Okay. Opening up. Okay. So we'll get rid of the green. Okay, so there's our vertex. Okay, so when we now know that it's opening up, is x squared or is y squared? X is squared. So x something squared y something. And 4p is here. Okay? Is it x plus 3 or x minus 3? Minus. Is it y plus 3 or y minus 3? Okay. Now, we don't know what p is, do we? Yep, we can plug 0, 0 in to figure out what p is, because this has to satisfy our equation of our parabola. So when we plug in 0, 0 minus 3 squared equals 4p times 0 plus 3. So negative 3 squared equals 4p times a positive 3. So if we have 12p equals 9, someone asked me for a fraction for p, And that's okay. P is going to be 3/4. So now we could get our focus and our directrix, couldn't we? We would simply move 3/4 of the way up, 3/4 of the way down, and we're set. Okay. You don't, it doesn't ask you for it, just a completion to wrap it up in a nice neat bow. So the last step then is to rewrite it as x minus 3 squared equals 4p times, or 4 times 3/4 y plus 3. Okay. All right, I'll give you the assignment, and then there was a question about one of the problems from homework. We'll look at that. Okay. In your calendar should be on your phone. Did I give you the same one? No. Same page. We're just on 47 through 56. Yes. So did I have overlap? I had 48 before. Okay. So this should be given pieces. Give me the equation of the line of the parabola.